Let's look a little closer now at speed. Now, much like we did on a graph, if we relate distance and time, we can determine the speed an object has traveled, which is really the distance an object travels, and we're going to use this symbol delta d divided by the time interval delta t. Change in distance, change in time. So speed is really distance over time, much like kilometers per hour, speed of a car. Distance, we say, is delta d, and time is delta t. And we're going to use abbreviations throughout physics a lot. We don't like to write words, we're going to write abbreviations. So if we had a car traveling 120 kilometers in an interval of 2 hours, these numbers are the quantities we're going to try and determine. Well, the first one we can look at is just the units, kilometers and hours. Kilometers is clearly a measure of distance, delta d. Our delta d then is 120 kilometers, and when we say 2 hours, that represents our delta t, our time. And then we could use these quantities to find our speed if necessary. Often when an object is moving, though, it is not traveling at a constant speed. Its speed is changing, slowing down, speeding up along the way. So when we're calculating speed, we're going to use an average speed. The average speed is given as the total distance an object travels divided by the total time taken. Total distance divided by total time. An average speed is actually a formula, and we can use this symbol, and this is what we're going to use. Average speed, VAV, is going to represent average speed, and average speed is delta D, the total distance, divided by the total time. Now sometimes we're given total distance, total time. Sometimes we're just given the D final, D initial, T final, and T initial. And D final and T final refer to the final position, the distance at the end of the motion, the time at the end of the motion. And along those same lines, DI and TI refer to the initial position, the starting point and the ending point. Now when we are measuring an object, often it starts at 0. So very often our D initial and T initial turn out to actually be 0 when we do our calculations. So let's look at a calculation. Here's a little sample calculation, and here's a person out on a walk, and they pass the 2-kilometer mark at 3:05 p.m. and then the 4-kilometer mark at 3:55 p.m. Our question is, what is their change in distance and change in time? So the important thing when we do questions like this is to recognize numbers. Here's a number, 2 kilometers, that's going to represent something. Well, I might as well do the other distance. There's a 4 kilometer. Those two together are going to matter. Well, this is clearly 2 times. And what we're trying to find in this case is their change in distance and their change in time. So the first thing we always want to do is write down our given information. First piece of information, 2 kilometers. That's the initial distance. That's where they start timing or look at their clock for the first time. Well then, if that's the initial distance, clearly the initial time is 3:05 p.m. That's our starting time. That means the other numbers are the final distance, D final, or DF is 4 kilometers, and our final time is 3:55. And the question says, what is their change in distance, their delta D, and their change in time? These are the numbers we have to actually calculate. So let's start with change in distance. And change in distance, as we already looked at before, is really just D final minus D initial. And the final distance and the initial distance are just already given above. Just plug them in. D final is 4 kilometers. D initial is 2 kilometers. We're just going to subtract them, and in the end we get 2 kilometers an hour. Final minus initial. That would be our change in distance. And the exact same thing happens for time. We take our final time minus our initial time, and our final time is 3:55 p.m. The initial time is 3:05 p.m. What we have to be careful about here is we're dealing with time. We just can't throw that in a calculator. We have to actually think about the clock. So 3:55, 3:05, between those two, there's 50 minutes. And that would be our delta t. Now we may want to take that and convert it into seconds or hours, but that would be for a later question. So the important thing in a question like this is that we take all of our given information, and here's our given information, the numbers that were in the original question, and answer what the question says. Find the change in distance and the change in time. Let's look at another example. If a person walks 8.5 kilometers in 2.2 hours, what is their average speed? Again, we always want to start with what given information do we have. We have something in kilometers, which is our delta D, 8.5 kilometers. We have something in hours, which represents our delta T, our time. And the question is, what is the average speed? So V average is what we're trying to find. Now, the good part about these calculations is on your data booklet, you have formulas on the back, very back page of your data booklet. And what we want to do is we want to find a formula that deals with all of our given information. We want to find a formula that deals with delta D, delta T, and V average. So we just turn to our formula sheet, find a formula that deals with delta D, delta T, V average. It's pretty clear it's that first equation. That's going to be the equation that we use to do our calculation. So we just take our equation, transfer it to our page. VAV is delta D over delta T. Well, we know our numbers. We've already written those down. Delta D is 8.5 kilometers an hour. Delta T is 2.2 hours. Fire those in our calculator and we get 3.9 kilometers an hour. The only thing we have to do now is answer the question. And the question was, what is their average speed? So the average speed is 3.9 kilometers an hour. And it's really that simple. Write down your givens, find the equation, plug them in, answer your question. Now, if you look at your formula sheet, you'll see there's other variations of the formula that we can use to find either the distance or the time if we're given the average speed. Such as this situation. A person walks for an average speed of 4.3 kilometers an hour for 45 minutes. Our question is, what is their total distance? Now, just like before, we're always going to write down what our given pieces of information are. We are told the average speed is 4.3 kilometers an hour. We are told their delta T, the time, is 45 minutes. The one thing we want to note here, though, is this is in hours and this is in minutes. And in terms of calculations, that's not going to work. We need to be in the same unit of time. So just convert minutes into hours. And it's really easy to convert minutes into hours. Just take 45 minutes and divide by the number of minutes in an hour, which is just 60, and we get 0.75 of an hour, 3/4 of an hour. Now the question is asking us to find the total distance, the delta D. This is where we go back to our formula sheet. We're given speed and time. We want to find distance. Well, there's a formula right there. Delta D is VAV times delta T. Distance is speed times time. That's the equation we're going to use. Now we just plug in our numbers. We have the VAV and the delta T. VAV is 4.3 kilometers an hour. Delta T is 0.75 of an hour. Fire them in your calculator and we get this number, 3.225 kilometers. And as before, we need to answer the question, what's their total distance? We usually round to 2 decimal places, and we get a total distance of 3.2 kilometers. Now that's how we do calculations for speed. We can actually also look at the instantaneous speed of an object. And sometimes we're trying to find how fast an object is moving at a particular point in time, a particular instant. An example of this is a speedometer on a car. You may be traveling at an average speed of 100 kilometers an hour, but your car speedometer will read the instantaneous speed, the speed that you are traveling at one instance in time. Now there is a situation where your average speed and instantaneous speed can be the same thing. And that's if you're traveling with a constant speed. And constant speed is what we refer to as uniform motion. And we're going to look at a lot of examples of uniform motion. And when we have uniform motion, the average speed is equal to the instantaneous speed. And if we're looking at the car example, we can have an average speed equal to its instantaneous speed if we just turn on our cruise control. Keep the car traveling at a constant speed. And we're going to look at uniform motion in more detail and do some more calculations with this throughout the class.